if we're going to do an example, let's take our first case as all of the resistances are the same. So in this case, I put them to 900 ohms each, and the potential difference applied is 9 volts. So we have our formula that we derived, 1 over R total equals 1 over R1 plus 1 over R2, R3, 1 over RT is going to equal 1 over 900 ohms plus 1 over 900 ohms plus 1 over 900 ohms. 1 over R total equals 3 over 900 ohms, right? Because we're just adding these fractions. The denominator is the same, so you just add them at the top. And so that's the inverse of it. So if we divide it, if we multiply, if you flip it, to make it 1 over R, it'll give you R over 1, which is just R, equals, and then flipping the other side, 900 over 3, which gives us a total resistance of 300 ohms. And a good thing to remember in case you want to check your work is that in parallel circuits, the total resistance is always going to be less than your smallest resistor, resistance. So let's do a second example. Let me put these units in pink. The voltage supply doesn't really matter because the only value you need is your resistances to find your total resistance. So for this case, let's take this one to have a resistance of 10 ohms, 2 ohms, and let's say 4 ohms. Okay, we have different resistances now. And I'm just going to go to the other side. So we'll do the same thing. 1 over R total is going to equal 1 over 10 ohms plus 1 over 2 ohms plus 1 over 4 ohms. Now, you can either change all of these denominators just to add them or just put it in your calculator, but we know that this is 0.1 plus 0.5 plus 0.25, which gives us 6 plus 7, 5. 0.85 ohms, 1 over RT. And so how do we find RT, not 1 over RT? We just flip it. So 1 over RT becomes RT over 1, which we can ignore because RT over 1 just equals RT, equals 1 over your 0.85 ohms, which is going to give us 1.18 ohms. And if you notice, this is correct because 1.18, what is our smallest resistance? 2. And it is smaller than that, so we know that everything's good. Thank you.